Hello students, how are you all? Welcome to AP Calculus. So today in this video we are going to learn about how to find the arc length of polar curves. So this is a really important topic and today we are going to discuss 5 important questions which will really boost up your concept regarding this. So let's start. So the one thing over here is the formula which we are going to use. Any polar curve which will be given in terms of r is equal to f of theta, right? So here we are going to use this particular thing. These two formulas, either it will be written in terms of r or it will be written in terms of f theta. So the first type of formula, you can say the length of the arc will be equal to alpha to beta. Integration from alpha to beta means from this angle to that angle, and square root of r square plus differentiation of r with respect to theta whole square and d theta. The another method or another formula, same thing is there, only thing is that r is written in terms of f theta. So it is f theta whole square plus f dash theta whole square. That's it. Both are the same thing, right? So let's start with the questions on this. This is the question number 1. Find the length of the arc from theta is equal to 0 to 2 pi for the cardioid r is equal to f theta is equal to 2 minus 2 cos theta. So here what is alpha? Alpha is 0 and beta is 2 pi. Now r is also given. So the length of the arc will be from 0 to 2 pi square root of r square. R square means 2 minus 2 cos theta whole square plus differentiation of this. Now what is dr over d theta over here? If you differentiate this, differentiation of 2 will be 0 and cos theta differentiation is minus sin theta. So basically it becomes twice of sin theta. So it will be twice of sin theta whole square. Now we just have to evaluate this thing. So if you expand this thing, it is a square plus b square, and since it is a minus b, so it will be minus 2ab. So minus 8 cos theta. This will become 4 sin square theta d theta. This is going from 0 to 2 pi. Now first main thing is to simplify this. Now this term 4 cos square theta and 4 sin square theta, we can take the 4 common and it will be sin square theta plus cos square theta minus 8 cos theta. Now in this one also, this sin square theta plus cos square theta will become 1 and this 4 plus 4, that will become 8. So 8 minus 8 cos theta d theta. Now from here also we can take the 8 common. So it will be 1 minus cos theta. Now in order to remove this thing, we have the identity cos 2 theta is 2 cos square theta minus 1 and another one is 1 minus 2 sin square theta. For this one, we will be using the second one. 1 minus, so here, this is the double angle formula. We can use the half angle also. So we can say cos theta is equal to 1 minus 2 sin square theta by 2. So 1 minus cos theta is 2 sin square theta by 2. So that will become 8 and it is 2 sin square theta by 2 d theta. 0 to 2 pi. Now this 8 times 2 is 16. 16 will be taken out of the root. That will become 4. And square root of sin square theta, that will open with mod of sin theta by 2. Always remember the important point. Whenever you are opening square root of x square, it will always open with mod of x, absolute value of x, so that you can decide. Now here we are, how we have to open it, whether it will be open with the plus or minus. Now how we are going to open it, let's see. So here we will see, since theta is going from 0 to 2 pi, so it is sin theta by 2, so theta by 2 will go from 0 to pi, and theta by 2 going from 0 to pi in this first and second quadrant, sin theta by 2 will be positive. So therefore it will open with 4 sin theta by 2. This is the simplification up to here. Now we will do the integration. Integration of sin theta by 2 is minus cos theta by 2 and divided by 1 by 2 also. and the limit is going from 0 to 2 pi. So this 1 by 2 will go in the numerator, it will become minus 8, and minus 8 can be taken out. So it will be minus 8, and cosine of theta by 2 from 0 to 2 pi. So let's put the values now. If you put 2 pi over here, so it will become cos of pi minus cos of 0. Cos pi is minus 1, cos 0 is also 1. So minus 8 times minus 2, that comes out to be 16. So length of the arc in this is 16. That's the answer. Let's move on to the second question. Here it is written r is equal to 4 sin theta. So theta is going from 0 to pi. So we can say that alpha is equal to 0 and beta is equal to pi. Now again the formula for the length is alpha to beta square root of r square plus dr by theta whole square. Now what is dr by d theta? Differentiation of this will be 4 cosine theta. Let's substitute everything. 0 to pi square root of 16 sin square theta, and dr by theta whole square will be 16 cos square theta. This one is quite easy because 16 if you take common, so it will be sin square theta plus cos square theta, and that's a standard identity. Sin square theta plus cos square theta is 1. So we'll be left with only square root of 16. Now square root of 16 is what? 4. So 4 d theta. 4 can be taken out of the integral. So it is basically 1 d theta. So integration of 1 will be theta with respect to theta, and 0 to pi we are integrating. So if you put the upper limit minus lower limit, that comes out to be 4 pi. So the length of the arc is 4 pi in this particular question. This was quite easy one. Now let's see this third question. This is the important one, we should say. The working over here without the calculator we are going to do, and the working is really important over here. So let's see. Alpha is 0, beta is 2 pi, dr over, and let's say what will be the dr over d theta? That will be 1 differentiation is 0, sin theta differentiation is cos theta. So let's put everything in the formula. 0 to 2 pi square root of a square, this r square plus dr by theta whole square, and with respect to theta we have to integrate it. Now one way is you can use the calculator for this, but suppose if this question is the non-calculator one, so let's see how we can proceed. So 1 plus sin square theta, a square plus b square plus 2 sin theta, if you open it, and it will be cos square theta. Now sin square theta plus cos square theta, that will become 1, and this 1 plus 1 will become 2. So 2 plus 2 sin theta. We can take the 2 common, it will be 1 plus sin theta. The integration is going from 0 to 2 pi, 0 to 2 pi. Now the interesting part over here is, in the first question if you see, that was 1 minus cos theta, so we can convert it into this format. 1 minus cos theta was, so we can convert like this. But we don't have anything for 1 plus sin theta. Direct formula we don't have for 1 plus sin theta. So the approach will be a little bit different in this case. So what we have to do, we have to remove this square root. So we have to convert into the perfect square. Now how to convert this into perfect square? That's really interesting. So we will say this 2 as it is. Now 1 plus sin theta it is. So we can write 1 as sin square theta by 2 plus cos square theta by 2, and sin theta can be written as 2 sin theta by 2 cos theta by 2, because we have one identity also in sin 2 theta. It's 2 sin theta cosine theta. So sin theta will be, angle will be half, 2 sin theta by 2 cos theta by 2. What will happen due to this? You can see it is something like a square plus b square plus 2ab. So we can say it is a plus b whole square. But again, the interesting part over here is you cannot directly remove the root, right? We have to open it by modulus or absolute value. So root 2 can be taken out, but it will be opening like this: modulus of sine theta by 2 and cosine theta by 2 d theta. The square root and root, again the same concept, square root of x square will open with absolute value of x. This is the most important step in this question. Now we have to decide how we are going to open it. Just like in the previous one we have decided, here also we have to decide how we are going to open it, whether with the plus or minus. So theta is going from 0 to 2 pi. So in the 0 to 2 pi, sometimes it will be plus and sometimes it will be minus. So since these are the two different trigonometric function, so let's convert into the single trigonometric function. Now to convert that into single trigonometric function, I am going to use one concept: sine theta by 2 cos theta by 2. The coefficient of these is 1 and 1. This is 1 and this is 1. So let's do one thing. What is square root of 1 square plus 1 square? The square root of the sum of the square of the coefficient, which is square root of 2. So let's multiply this by square root of 2 and divide by square root of 2, like this. So now we can see that this is 1 by root 2 sine theta by 2 and 1 by root 2 cos theta by 2. So 1 by root 2 can also be written like this: cos of pi by 4. This is nothing but cos pi by 4 and it is sine theta by 2. This can be written as sine pi by 4 and cos of theta by 2. So we can say now this part, it is getting one identity: sine a cos b plus cos a sine b. So that can be written as sine of a plus b, sine a cos b plus cos a sine b. So this expression can be written into a single trigonometric function like this. Now we will see where this is getting 0, because this is the absolute value inside this. So we'll see how we are converting into 0, how this is getting converted into 0. That's the most important part over here. Now let's see that thing. So we'll say now this question has been converted like this: square root of 2, 0 to 2 pi. The absolute value of this part, this is square root of 2 sine theta by 2 plus pi by 4. This is the thing. Now let's take this root 2 outside it, so that will become 2, 0 to 2 pi. So absolute value of sine theta by 2 plus pi by 4. Now we have to open it. So what we will do, let's put this equal to 0 to figure out where this is getting changed. So here we will be doing sine theta by 2 plus pi by 4. We are putting it equal to 0 so that we can see where the sign is getting changed. So sine of something is equal to 0. So what are the possibilities? Like theta by 2 plus pi by 4 is equal to 0. Theta by 2 plus pi by 4, that is equal to another angle over here. We can say pi, because sine of pi is also 0. So if you solve this particular case, so we'll be getting theta by 2 is equal to minus pi by 4. So theta is equal to minus of pi by 2. But in the 0 to pi, minus pi by 2 is not there, so reject this thing. If you solve this, pi minus pi by 4 is 3 pi by 4 and theta will be 3 pi by 2. Yes, 3 pi by 2 lies between 0 to 2 pi. So we can say yes, here we can accept this thing. Now, second thing over here, if you take the another one, let's say 2 pi also, sine is 0 at the 2 pi also. So we can take the one more case. This is equal to 2 pi. So let's see on the 2 pi what is happening. So theta by 2 will be equal to 2 pi minus pi by 4. So this will be 8 minus 1, 7 pi by 4, or theta will be equal to 7 pi by 2. 7 pi by 2 is more than that 2 pi. So we'll reject this one. And since also if you take a higher value, the theta will be higher than the 2 pi. So this is the only one theta value which we are getting. So now we can see in the 0 to 2 pi, this is 0, this is 2 pi, 3 pi by 2 will be somewhere over here. So we'll break the integral from 0 to 3 pi by 2 and 3 pi by 2 pi. So in the 0 to 3 pi by 2, this expression, the sine theta by 2 plus pi by 4 is going to be positive, and here it is going to be negative. And how? You can again cross check this thing, like whether it is going to be positive or the negative. Let's check it like this. Suppose I want to see from 0 to 3 pi by 2, when the theta is going from 0 to 3 pi by 2, where this theta by 2 plus pi by 4 is going. So suppose if the theta is going from 0 to 3 pi by 2, I want to create theta by 2 plus pi by 4. So if you divide this thing, so theta by 2 will be dividing by 2 on both the side. So that will be 3 pi by 4. Now adding pi by 4 on both the sides. So this is pi by 4, and if you add the pi by 4 over here, 3 pi by 4 plus pi by 4, that will be pi. So pi by 4 to pi, this is in the first and second quadrant, so this sign will be positive. That's why here it is positive, and here definitely it will be negative. So the absolute value will open with the positive and the negative sign. So now we will break it. So how we can break? From 0 to 3 pi by 2, so you can say 0 to 3 pi by 2, and the integral will be sine theta by 2 plus pi by 4 modulus of sine theta by 2 plus pi by 4 d theta, and then 3 pi by 4 to 2 pi. That's the thing. Oh sorry, 3 pi by 2 it is. 3 pi by 2 to 2 pi. And this is again modulus of sine theta by 2 plus pi by 4. Now the interesting part is, this is the integral we have to solve. This 2 is outside. Now since 0 to 3 pi by 2, this is positive, so this expression is going to be positive. So it will be simply sine of theta by 2 plus pi by 4, absolute value will be removed. 0 to 3 pi by 2, and here it is going to be negative. So it will open with a negative sign. So minus 3 pi by 2 to 2 pi, and it will be sine of theta by 2 plus pi by 4. Now let's integrate this thing. This was the most important step. Now integration of this will be, integration of sine will be negative cosine. So negative cosine theta by 2 plus pi by 4, and coefficient of theta is 1 by 2. So we'll be dividing by 1 by 2. So basically the 2 will get multiplied over here. So it will become minus 2. So we can say the integration is going from 0 to 3 pi by 2. This 2 is outside. Similarly, here if I going to integrate this thing, integration will be same. Minus 2 cosine theta by 2 plus pi by 4, and it is 3 pi by 2 to 2 pi. And there is one thing outside. Now let's simplify this thing. So we can put the upper limit over here. When we put the 3 pi by 2 over here, so 3 pi by 2 in this, so 3 pi by 2 divided by 2 is 3 pi by 4. 3 pi by 4 plus pi by 4, that is pi only. So minus 2 cos pi, and then if you put the 0, so if you put the 0 over here, so that will be only cos of pi by 4. So minus 2 cos of pi by 4. Similarly, when we solve this thing, here if you put the 2 pi in the first, so 2 pi divided by 2 is pi only, so pi plus pi by 4. So minus 2 cos pi plus pi by 4 is 5 pi by 4, minus lower limit if I am going to put, so 3 pi by 2 divided by 2 3 pi by 4, 3 pi by 4 plus pi by 4, 4 pi over 4, that is pi only. So minus 2 cos of pi. This is the thing. Now, so cos pi is what? Minus 1. Cos pi is minus 1, so that will become positive 2. Cos pi by 4 is 1 by root 2. So 2 multiplied by 1 by root 2, that will become, or root 2 over 2. So it will be minus root 2 will be there, but minus minus plus. So it will become plus root 2. That is the first part. minus. Now cosine of 5 pi by 4. Cosine of 5 pi by 4 is minus 1 over root 2. So this is minus 1 over root 2. So that will become minus 1 over root 2. So minus minus will become plus. So it will be plus root 2 over here. And then there is a minus. Cos pi is minus 1. So that will become minus 1 times minus 2. That will become plus 2. So it is like this. Okay, that's it. Now if we are going to solve it again, so you can see this will be 2 outside. Now what is there? 2 plus root 2 and minus root 2 plus root 2. When you open the bracket, it is minus root 2 plus root 2. This root 2 will also get cancelled, and 2 plus 2 is 4. So 4 times 2 is 8. So that is going to be the final answer. So this was the really interesting question based upon the calculation. So I hope you have understood this thing. You need a little bit of practice in this type of question when you have to solve the integration. Okay, let's do the next question. This is the question number 4. This is the calculator based question, quite easy. Here alpha is 0 and beta is pi. So simply what you need to do is dr over d theta we can calculate. Differentiation. So in the differentiation we'll be applying the chain rule. Differential sign is cosine of 3 cos theta. Then differential of 3 cos theta is minus 3 sin theta. So basically it becomes minus 3 sin theta times cosine of 3 cos theta. Now let's see the length. So length of the arc will be given by 0 to pi square root of r square. So it is sine of 3 cos theta whole square and dr over d theta whole square. That will become, if you do the squaring of this thing, let it be as it is. So minus 3 sin theta and cosine of 3 cos theta whole square. So the same expression you have to put it in the calculator. When you put the same expression in the calculator and when we will calculate it, the answer will comes out to be 4.388. That is going to be the final answer for the length of the arc. This is a simple calculator based question. Now similarly, let's see the last question over here. That's about the e power 3 theta. This is question number 5. So here the r is equal to e raised to the power of 3 theta. So we can say alpha is equal to 0 and beta is equal to 2, right? Now what is the dr over d theta? So if you differentiate this e to the power 3 theta, that is e to the power 3 theta times 3. So now the length of the arc will be 0 to 2 and square root of r square. So e to the power 3 theta whole square plus 3 times e to the power 3 theta whole square. Now so when you simplify this thing, e to the power 3 theta whole square will become e to the power of 6 theta. This will become 9 e to the power of 6 theta. We can add them. These are the like terms. So that will become 10 e to the power of 6 theta. So 10 can be taken out of the square root, and this square root of e to the power 6 theta, that will become e to the power 3 theta. Like we can say square root of 10 can be taken out, and e to the power 6 theta whole power of 1 by 2. So that will become e to the power, exponents will get multiplied, so e to the power of 3 theta. Now let's integrate this thing. So integration of e to the power 3 theta, that's going to be same e to the power 3 theta, but we have to divide it by 3 because the coefficient of theta is 3 and limit is going from 0 to 2. So 3 can be taken out of this integral. Now if you put the upper limit 2, so e to the power of 6 minus, if you put 0, so it will be 0. So finally it is going to be root 10 by 3 e to the power 6 minus 1. This is going to be the final answer for the length of the arc. So I hope you have understood all these 5 questions. Now I have given 2 questions for the homework practice. These are the answers for this. You have to find the length of the arc for these 2 questions. and if you need the solution of this, you can message me on this particular WhatsApp number. So these are some really good questions we have covered, out of which the third question was really important from the calculation point of view. That's it. Okay then, so that's all for today. So if you have any particular doubt related to the AP calculus, you can send me a doubt over this particular WhatsApp number. Thank you for watching.